Petroleum or crude oil is often composed of large fractions, in other words molecules that are very large and not terribly useful. So we use a process called cracking that breaks down these large molecules into smaller, more usable ones. So cracking is a chemical process and involves breaking down large hydrocarbons into smaller ones. And most of the fractions that it forms can be used in petrol. Petrol, of course, is in huge demand all over the world as a preferred choice for fuels for vehicles. Often we end up with a mixture of alkanes and alkenes in the mixture that forms after cracking. There are two methods of cracking, and one is using heat, thermal cracking, and the second is catalytic cracking. So they have different characteristics, different conditions. Thermal cracking occurs with no air, high temperature and high pressure, whereas catalytic cracking needs lower temperature and lower pressure. So it's a more affordable way to go. As you're aware, in industry, creating conditions of high pressure and high temperature can be very expensive. The catalyst used is a silicon dioxide, which is found commonly in natural areas, sands, clays, that sort of thing. And that formula should be silicon dioxide, SiO2, not SiO. There are twos on the next line. Aluminium oxide is another option that can be used as a catalyst. Let's have a wee look at the video on the next clip, on the next slide.
Cracking is a chemical process that enables the conversion of high boiling products to low boiling ones. There are two methods of cracking. The older one, called thermal cracking, involves heating long-chain hydrocarbons under pressure in the absence of air. Under these conditions, they break down into shorter-chain hydrocarbons. Most of them fall in the range required for petrol. The newer method, catalytic cracking, takes advantage of materials called catalysts, allowing the reaction to proceed at a lower temperature and pressure. In this process, finely powdered clays play the role of catalyst.